When we do logarithmic differentiation, that means we take a logarithm of both sides and then take a derivative. So we're taking a natural log of the original function. We're taking a natural log of the other side so that we keep it balanced. Okay, so when we take a derivative of both sides, we'll want to keep in mind that we're finding 1 over f of x. Okay, because the derivative of natural log, we need to multiply by the derivative of the innermost function. The derivative of the logarithm. And then when you find a derivative of the innermost function, that's f prime here. So that's the chain rule. So just check out that left side. When you take a derivative of a natural log, it's 1 over the argument, so it's 1 over f of x, and then times the derivative of the innermost function. Okay. So when we're done rewriting this right side, we're going to want to remember we have to solve for f prime of x. That's the whole goal. So we're going to have to do a little bit more algebra over here. So the derivative of the right side, the 4 comes down and multiplies. Yeah, so I should put this in brackets because this part is being raised to the 4th power, not the logarithm. Right, so I think I just got confused there. So when we take a derivative, it's the natural log first. So when you take a derivative of a natural log, it's 1 over whatever's inside the parentheses. And so if it's 1 over a fraction, you could just find the reciprocal of the fraction. So the derivative of natural log of all this stuff is 9 minus 5x over 1 plus 2x squared. And then we need to multiply it by the derivative of the innermost, this is all to the 4th power. So now we need to multiply it by the derivative of the innermost function of this stuff right here inside the brackets. So that's where 4 is going to come down and multiply. And then we still have another innermost function. We took a derivative of the 4 was a power, so the power got reduced to be 3. And now we need to multiply by the derivative of the next innermost function. So we need the quotient rule. This question's pretty crazy, huh? So the quotient rule says the derivative of the top function, so that's 4x, times the bottom function kept the same, minus the top function kept the same, times the derivative of the bottom function. That's all over the bottom function squared. Okay, so that's the derivative of the right side. What a crazy question. So for algebraic simplification, I'm going to write out every step because there's so much here I could lose something. For algebraic simplification, you could raise both the top and the bottom to the 4th power. Because we're going to see something cancel out over here. This is 1 plus 2x squared. That's all to the 3rd power. And then we got 9 minus 5x to the 3rd. And then all this stuff we could distribute to try to maybe combine like terms over here. 4x times 9 makes 36x. And then 4x times negative 5x makes negative 20x squared. And then we need to subtract that by negative 5 being distributed everything in here. So I'm going to keep it in parentheses for right now. It's all over 9 minus 5x. That's being squared. Okay, so the whole point over here is that you got a 9 minus 5x to the 4th times something over 9 minus 5x to the 3rd. So that can cancel. That goes down to a power of 1. Same thing over here. That cancels. That goes down to a power of 1. So 1 over f of x times f prime of x equals 4 times 9 minus 5x over 1 plus 2x squared. And then over here, when we distribute that negative sign, looks like this. Oh, what else can we do? Oh, so we got a 9 minus 5x in the numerator. We got two 9 minus 5x's in the denominator, so let's cancel that out. And then we can also combine like terms over there. So my hand is killing me, but I'll copy this down because I don't want to lose anything. What a crazy problem. So multiplying these together, it's 4 times this entire numerator in parentheses. Negative 20x plus 10x squared, negative 20x squared plus 10x squared makes negative 10x squared, plus a 36 plus 10. That's all over, got 1 plus 2x squared, and 9 minus 5x. And the problem is still not done. There's still a bit of work to do because we still have to solve for f prime of x. I'll show you that in just a second. It's easiest if we can clean this up. You could factor out a 2. That's going to give you 5. That's not going to help us, though. So I'm going to leave that for right now. Because we're trying to solve for f prime of x, the derivative, right? So to get the derivative, we got to multiply f of x to both sides. So it means f prime of x equals f of x times all this stuff. I'll just use quotes because we're going to plug in what the original function was. The derivative is the original function, 1 plus 2x squared over 9 minus 5x all to the fourth. And then it's times all that stuff we just wrote up here. 4 times negative 10x squared plus 36. Oh, I dropped an x. I'm sorry. So this is 36x. 36x plus 10 all over 1 plus 2x squared 9 minus 5x. So there's our derivative. That's what. Should be able to enter that in WebAssign and get the correct answer for these numbers in this problem. Sorry, so when looking at my answer, I went back here, minus a negative 5. That should be plus 5, not plus 10. So that should be plus 5 here. Okay, that's the tough thing about such huge problems like this is that one little mistake like that's just a mental lapse. I saw a 10 coming up, so I wrote a 10, but that's supposed to be a plus 5 there.